Just the one example today, given the diagram, it's still going to be use SOHCAHTOA whenever you can, and if you can't, use sine law, cosine law. And when we look at this question, like what I'm going to say first, what's going on here, is this, well, there we go. This is not an angle. Not an angle that we can use. Because this triangle, let me get a better pen here. I'll use a highlighter. This triangle is on the ground, and this one is standing up. Doesn't want to draw over top of that tree. Okay? So some of the angles aren't shared, and this one here is one of them. That's not an angle in the diagram. So you just have to make sure that you visualize these. What's really interesting, what's going on in this question? Anybody tell? I mean, it's just kind of a cartoonish question, but there's something really interesting going on here. Trying to find the height of a tree, so what?
Oh, I don't know. I just think so there's no side that's all angles.
There's one side length. If there wasn't a side length, yeah, 40 feet, right? That's okay. If there wasn't any side lengths, you wouldn't be able to solve. You need at least one side length to solve. Anybody have any idea? Yeah? So this is like, for some reason, you're surveying, I don't know, land, and you need to know the height of the tree, but you can't get to it because you're stuck on the other side of a river. And yet with trigonometry and relatively rudimentary tools, you could determine the height of a tree fairly accurately. There's something called a clinometer. You might have seen it in grade 10. You might have used it. And you can make one out of like a ruler or a toilet paper roll or something like that. And basically what you do is you hang a string from not actually a ruler, you would hang a string from a protractor, okay? And when you look along the protractor, the way the string hangs tells you what angle you're looking at relative to how you're standing. So these days, they would do this with lasers, right? And you would take a laser and you'd probably just point it at the top and point it at the bottom. In fact, you probably have apps on your cell phones that can even do it fairly accurately. Now, it's probably doing some of these same kind of math in the background. But anyway, but they would tend to do it with lasers. And if you've ever seen construction crews on the side of the road with those tripods that has like a thing on it and it looks like a camera, those are like laser sights that are going from one to the other that are measuring distances and angles and stuff like that, I think. So they would do this with a laser, but you could do it with a tool that you could make with a protractor and some string. And you would have to measure that 50-degree angle with a clinometer. Okay, that's what a clinometer would be. It measures like angles up to things. And then you'd have to have a way of making sure that you walk straight across, but that would be easy to measure. You can measure the 40 feet. Right, across here with tape measure or by counting at steps or something. And then you'd have to find a way to measure the 35 and the 40 degrees accurately, but I think you could do that. Again, even with a protractor and some kind of thing pointing at the tree. If you did it carefully, you could get decent measurements for those. And you could find measurements of things that you don't have access to. And in fact, I think this is how they used to do these kinds of things. Or you could measure the height of a cliff this way that you might not be able to get to, or a mountain or something like that you might not be able to get to some extent at least. So it's kind of interesting. Again, trigonometry, I said this the other day, has these real life uses. I know maybe you can't picture yourself doing this, but you never know what kind of job you're going to find yourself in someday. And you can see how this is useful stuff in the real world. So we are trying to find the height of the tree. It's good to mark that on your diagram and give it a variable. You know how in some of the other units that we've done already when we're doing applications and we go, let X represent something. That's what we're doing. Let h represent the height of the tree. We're just being lazy about it and drawing it on the diagram instead of doing a let statement. But it's the same thing, so you should put that on there. Sometimes the thing you're trying to find isn't as obvious where it is in the diagram, that kind of thing. So that can even be part of the solution, is figuring out what in the world it's actually asking you to find. And now I have to determine, what do we know? What can we find? What's useful? What do I need in order to find h? I would hope and I would imagine most of you already have an idea of where this is going. But think about this. If I could find this side length from here to here, would I be able to find h? Brooke, what do you think? So if I have in this triangle, if I know a side length, let's say it's, I don't know, 80 feet, and I know an angle, can I find the other side length? Yeah. SOHCAHTOA, when you have a 90-degree angle, you only need one side length, one angle. You only need two pieces of information to find a third. And with those two, you can find any third you want. So if I knew this side length, I could find h. Can we find that side length? Can't find it. It's not a shared length. This bottom triangle doesn't tell me anything about that side, which is the hypotenuse of that other one. Not going to help. So what am I going to do?
Find like both of the angles that you don't have.
Yes. Good.
And then you can use that to find the side that they share.
So this is the side that they share. And it's the distance from this point to the bottom of the tree. And they share that side, and I can find that if, Zach said, I think what you were saying is this angle here. So what is that angle? 105. How did you get that?
180 minus 30 minus 40.
So 180 minus 35 minus 40 equals 105, and that's that angle there. And now, this is not a right triangle, so I can't use SOHCAHTOA. So I have to decide, is it sine law or is it cosine law? Oh, and by the way, I'm going to give this side length a name as well. So 4x, what is it, sine law or cosine law? Sarah? Sine law. We know because we have a pair of an angle and a side length across. We also know because cosine law is either three sides, which we certainly don't have, because we're trying to find a side, or two sides in the angle between. And we certainly don't have that. We only have one side. So it's definitely sine law. So this is going to be, and then x is across from the 40. So this is going to be x over sine 40 equals 40 over sine 105. It's confusing when you have 40, like the same number in there twice. But this 40 is that one there, right? Because it's an angle, and it's the one that's across from the x. Okay, go ahead and solve this. You don't have to wait for me. And we're definitely going to use this answer in our next step. So you're going to keep it on your calculator, write out 4 decimal places, and make sure we can get it perfect. And I got 26.6185 if you keep 4 decimal places. Is that what other people got? Lovely. And sometimes it might help to like equals 26.6 to put it in your diagram. That can be a useful technique. Some of you don't need to do that. You already know what's coming next. But it can be useful to label them, the numbers you find in the triangles or in the diagram, so then you know what you know and you can visualize better. What am I going to do next? Ellie?
Find the like we use Sine Law. So we use 50 and x and 26 and 6 on the
Good. Now hold on. What kind of triangle is this? A right triangle, so I can use SOHCAHTOA. Some people get in the habit of using Sine Law for everything because Sine Law works in all right triangles. Please don't. Try to use SOHCAHTOA when you have a right triangle. It would work. You'd have to find a little bit of extra information. You have to find the other angle up there, but that would be easy. Okay, so it's SOHCAHTOA. So I think we should use SOHCAHTOA. And so SOHCAHTOA is label your triangle, pick which one you're using, all that good stuff, right? So, and I don't need to find this because I was talking about that before, but now we have the other side length, so we don't need that one, right? So if I'm using 50 degrees, we talked about this. Some people, even though you don't need to, find the other angle, but then they get confused about which one they're using in the last step of this. And if you use the wrong one, your answer is wrong. So I would say don't bother. If you don't need to, don't bother. So you don't confuse yourself. Stick with the 50, which means this is opposite. And 26.6 is adjacent. Opposite over adjacent is tan. So for H, I've got tan of theta is equal to H over X, which means tan of 50 degrees equals H. That's what we're trying to find over X, which is 26.6, which I still have on my calculator. 26.6 tan 50 equals H. So H equals, so 20, I've got it on my calculator. I just go times tan 50. 31.7 rounded to one decimal place. And we were talking feet here, therefore the tree is 31.7 feet tall. If you don't know that one little like apostrophe or tick mark, quotation mark is feet, that's fine. You can always ask. 2 means inches, 1 means feet. This might be something good to know. And that's it. So again, 3D shapes, some people aren't very good at visualizing. You might find 3D shapes a little bit difficult. But the nice thing is the diagram's given to you. You just have to figure out, you just have to problem solve how to find what you're supposed to find.